All right, so this is for 4.5. We did some examples that needed StatKey to get the p-value. So I'm going to show those here. It was with the testing of the new drug, and then also for the human body temperature, or the normal human body temperature. So we're looking first at this one here, where we're comparing to see whether the new drug would have a lower amount of relapse than just having a placebo. So we're doing a less than, and that's going to be a left tail test. The statistic is something that we could calculate if we had the table, but it's also the statistic is something that we're going to have available when we get over to StatKey. So right now we're trying to see whether there's enough evidence that the new drug is less. And right now the statistic is showing that it's minus 0.416 of a proportion smaller than if they had placebo. So the statistic is suggesting that the new drug seems to be doing better. A lower proportion are relapsing when they use the new drug. Now, what we need StatKey for is to be able to get our p-value. And so what I'm going to do here is switch over to StatKey. Let's see, StatKey. And you'll do a similar thing for your homework, but pay attention to which type of test you're doing: single mean, single proportion, difference in means, or difference in proportions. Right now, we're comparing whether there's a difference in proportions. So you'll click on that. And then you need to make sure that you select the data set that you need. Right now, we're doing cocaine addiction, desperamine relapse. And so you'll see that here's your statistic. Specifically, it's already what's been subtracted. The negative 417 or negative 416. It seems like we have slightly different calculation than the actual data table, but we're going to go ahead and go with 416, just because that's what we calculated in the lecture. Now, to get 1,000 bootstraps, you'll click on your generate 1,000. So you'll see all your samples here. And then over here, you'll click on which tail you're doing. And right now we're doing a less than. So that's going to be a left tail test. And I'm going to click it. And what that's going to do is give you the controls down at the bottom. And so regardless of whether this right here is where your statistic needs to go, that's where we need to put the 416. Sometimes it's already there, but it doesn't automatically update your p-value. So regardless of whether that bottom statistic already has what you need or don't need, just go ahead and do it yourself. So I'm going to click on this bottom box, and I'm going to put a negative 0.416, which is the difference in proportions. And so that's what you need to have, is you need to put down your statistic in order to get the p-value that's going to be floating right above it. And so what it just did is it said 5 out of 1,000 of these samples are as this extreme or more extreme. Again, this is the p-value showing that it's very significant. It's less than the 5%. So I'm going to take the p-value. We don't need to multiply it times 2. That's because we're doing only a single tail test, a less than. So you'll put your p-value here. .005. So that is your answer for part C. But then why should we reject it? As you see with part D, that's your generic conclusion, is because it is less than the level of significance. And the level of significance will be given to whether you should do 1%, 5%, or 10%. So we would reject, and we would say that it does seem that the new drug has a lower proportion that relapse. And I want to do one more just to show again, how do you get the p-value? So this one is doing a single mean, or the average of 98.6. And it is a two-tail because they're seeing whether there's a difference. So that is something that when we do get our p-value, that we're going to need to multiply it. P-value, get rid of that. This would be something times 2. Because it's doing, essentially, it's doing a less than and a greater tail test at the same time. We're considering either tails. So you're going to do your body temperature. So go back to the beginning of StatKey. Let me move this myself out of the way. StatKey. And this time we're doing a single mean. And the body temperature is already selected, so you don't need to change it. Just leave it as body temperature. And so there's your 98.26. That's what came from a sample. And you're going to generate 1,000 bootstraps. And this time, since it's not a left tail or a right tail, it's both. You're going to do a 2-tail. So I'm going to click the 2-tail little box, turn that on. And then at the bottom, you need to put your statistic. And so again, that's coming from the sample, which is 98.26. 98.26. So 98.6 in the middle. So you're going to put it over here to the left, 98.26. And this is the box that you need to click on to update. Whatever's here, even if it is already your statistic, go ahead and still put it because it always defaults at 0.025. It doesn't update your p-value the way that it should. So again, it was minus 98.26 is the statistic. Click on here, 98.26 and click OK or hit enter. And there's your p-value floating right above. So 0.000 of the samples are this extreme or more extreme. And so that is your p-value. Yes, you need to multiply it by times 2 in any 2-tailed test. But in this case, since it's 0.000, oops, it's still going to be 0. And that's the smallest p-value that we can ever get. And so there's your p-value. And then the reason why we would go on to reject the null hypothesis is because this is less than your level of significance. And they tell us right here, use a 5% level of significance. So even at 1%, it would still be considered significant. And you would say something like there's strong evidence that the body temperature differs from 98.6. All right, so that's just real quick on how to get your p-values. We'll do this more and more throughout the upcoming weeks as we do hypothesis tests, but I'm going to go ahead and stop sharing there and end this recording and get it uploaded.